All right, let's talk about air pressure. Remember that particles in a gas can vibrate and spin and move from place to place, and that as particles get warmer, they will naturally move faster. As gas particles move, they collide with each other and they collide with their container. And if they get warmer, those collisions become harder and more frequent because the particles are moving faster. The particles that are colliding with their container, that's called air pressure. So air pressure is the total force of all of those particles colliding with their container. As particles get warmer and their collisions get harder and more frequent, the force of their collision will increase. So therefore, the air pressure will increase. As particles cool and their collisions get gentler and less frequent, then the air pressure will decrease because the total force of all of their collisions will not be as strong. Imagine this is a sealed container with some gas particles inside of it. Gas particles will always want to move from an area of high pressure, so a region where they're under high pressure, to areas of low pressure. That will not matter if they're in a sealed container where the outward push of their collisions is the same as the inward push of the air particles pushing from the other side. So in that case, the container would remain unchanged because the outward force of all of those outward collisions is equal to the inward force of the inward collisions. And so the pressure inside of the container is the same as the air pressure outside of the container, and the container doesn't change. However, if we had collisions from the inside of the container get stronger, maybe because the gas was heated, if those collisions from the inside of the container were stronger than those collisions from the outside of the container could explode. It doesn't have to explode, but it might. The opposite is also true. If the collisions from the outside are much stronger than the collisions from the inside, then the container may crush. That might happen because the gas inside the container was cooled, or because some of it was drawn out, or because the container was moved to an environment where that outside pressure was much, much greater, like say under a large volume of water.